Friends, today we are starting with our third lecture. This third lecture consists of the VSEPR model of dichloroiodide host anion, pentafluorotellurate 4 anion, and tetrafluoroiodide third anion, and nitrogen dioxide. Serially, we are going to study the VSEPR model of these 4 molecules, starting with first one, that is dichloroiodide first anion, which is designated as ICl2 minus. On your screen you can visible that is in ICl2 minus ion. Iodine is a central atom whose atomic number is 53. In the ground state, it has the electronic configuration as, that is, krypton 4010 5s2 and 5p5. It undergoes sp3d hybridization, and here the diagrammatic representation of that one, that is, iodine has a 53 atomic number and its valence electronic structure, that is 5s orbital having 2 electrons and 5p orbital having 5 electrons, while 5d remains vacant. After a combination with the Cl2 minus ion, then the electronic structure is, say, like this. That is, you can see in your screen, that is, 1 electron get added here, and electronic structure of iodine in ICl2 minus ion in a hybrid state. What happens in a hybrid state? Electron is due to the ionic charge, and it will be added here, and you will get a sp3d hybrid orbitals, where lone pair of electron donated by chlorine ions that occupies this 5d orbital, which is designated by XX, and you can see that thus ICl2 has a 10 electrons, or we can say that the 5 pairs of electrons in its valence shell, 7 electrons of iodine plus 2 electrons from 2Cl. 1 electron is due to the ionic charge, and out of 5 electron pairs, 2 are the bonding pairs, you can see here, then which forming a 2 ICl single bond and 3 lone pairs. These 3 lone pairs of electrons occupy the equatorial position. You can see here there is a triangle. On that triangle, the vertices of the triangle that will be occupied by the lone pair of electrons, and axial position there will be a Cl atom. So the repulsion of 3 pairs do not distort the structure of the molecule, and the structure of dichloroiodide first anion is therefore a linear, because Cl, ICl, they are placed in a one line. The structure is shown here, diagrammatic representation, or we can say the linear structure of ICl2 minus ion. It is visible to you on your screen, and you can see here, that is, at equatorial position there is acquiring of lone pair of electrons, and at axial position there is a both Cl, and they are forming a linear structure of ICl2 minus. Then we move to the next, that is a pentafluorotellurate 4 anion, that is the TF5 minus. In this TF5 minus ion, the tellurium atom is a central atom. It has atomic number 52. In a ground state, it has the electronic configuration as krypton 4010, 5s2 and 5p4. The valence electrons of tellurium are 6, that is 5s2 and 5p4. In TeF5 ion, the tellurium atom has a 12 electron in its valence shell, that is 6 electron pairs, out of which 5 pairs are used for 5 tellurium F single bonds and 1 pair remain as a lone pair. The most stable arrangement for these 6 pairs is the octahedron, and the repulsion due to lone pair causes a chlorine atom to move away, giving a square pyramidal structure, which is shown in your figure. You can see here the square pyramidal structure. Here there is a 1 lone pair and 5 T E F bonds are there, and this is a structure of pentafluorotellurate 4 anion, which is shown on your screen. And this square pyramidal structure that should be observed. You are seeing all these things on your screen. Then here there is a next, that is ICl4, that is a tetrachloroiodide third ion. In ICl4 minus anion, the iodine is a central atom. Again, it has atomic number 53. In the ground state, it has the electronic configuration, say krypton 4010, 5s2, 5p5, and it undergoes the sp3d2 type of the hybridization. And you can observe on your screen how the electronic configuration of iodine in a ground state, then in an excited state, then in a hybridized state, all these things that are shown on your screen. In a ground state, both iodine and chlorine have a 1 unpaired electron, and that's why iodine gains 1 electron from to form I minus, and then undergo excited state to have a 4 unpaired electrons, and it undergoes sp3d2 type of the hybridization. After sp3d2 hybridization, iodine forms 4 bonds with 4 chlorine atoms, and the ICl4 minus contains 4 bond pairs and 2 lone pairs. The 2 lone pairs occupy the axial position to give the square planar structure. It gives the square planar structure as shown in figure 1.7, and here you can observe that is the 2 lone pairs and 4 bond pairs are there, and these 2 lone pairs occupy the axial position, and that's why in your diagram you can see that the 4 corners of the square planar there will be a Cl, and at axial position there will be 2 lone pairs of the electrons, and that is observed here, and again designated like 4 bond pairs are there and two lone pairs are there, and there is a square planar structure.